So let's have a look at question 4. Alkanes are saturated hydrocarbons with the general formula CnH2n plus 2, and that's just a lead into the question. A student carries out an experiment to measure the enthalpy change of combustion of hexane. The student finds that the combustion of 1.29 grams of hexane changes the temperature of 200 grams of water from 20.5 to 65.5 degrees C. And then we get to the meat of the question. Calculate the enthalpy change of combustion of hexane in kilojoules per mole and give your answer to an appropriate number of significant figures. So we are calculating the enthalpy change of combustion, and this bit's important, giving our answer to an appropriate number of significant figures. So we need to work out what an appropriate number of significant figures actually is. So let's have a look at the key data in the question. First of all, what are we trying to work out? Well, we're trying to work out the enthalpy change of combustion of hexane. It tells us the mass of hexane, 1.29 grams. It tells us the mass of water that's being heated up, which is 200 grams. And it tells us the temperature rise of the water, which is from 20.5 to 65.5. So we're going to need to use all of those numbers in our calculation. So these sorts of questions are fairly common. They involve use of the equation that relates the amount of energy to the temperature change of a fluid that you're heating up, which is Q equals mc delta theta. There is one more piece of information that we'll need to know, and that is what the C is, which is the specific heat capacity, in this case of water, because it's water that we are heating up. And that will be on your data sheet, and that will tell us that C for water is 4.18 joules per gram per Kelvin. Okay, so one of the tricky things in these sorts of questions is we've got m for mass in the equation, but we've got two masses in the question, and we've got to make sure we use the right one. And the way to work this out is to think about, well, what's actually increasing in temperature? It's not the hexane that's increasing temperature. We're burning the hexane, but we are increasing the temperature of the water. So our m in this equation is the mass of water, and our delta theta is the temperature rise, and in this case delta theta is from 65.5 to 20.5, so that is 45.0 degrees centigrade. So if we put those numbers into our equation, we've got Q equals mc delta theta equals 200 grams times 4.18. The units are okay because I've got a mass in grams and my C is joules per gram, times degrees C, 45.0. Now you might say, well, why am I able to use degrees centigrade when my C is per Kelvin? Well, the only difference between centigrade and Kelvin is the start point. So I can use, because I'm talking about a temperature difference, then I can use either. And that works out as 37,620 joules. Units are joules because my specific heat capacity was in joules. Now, in order to work out the enthalpy change of combustion, then I need to know the definition of what the enthalpy change of combustion actually is. And it is the enthalpy change when 1 mole of a substance is completely combusted in oxygen. And that key thing for this part of the question is that 1 mole. So I need to work out how many moles of hexane I've got. Luckily, they've told me the mass, so I know that to work out moles, my moles of hexane equals mass over mR. My mR I can work out from the general formula CnH2n plus 2 that hexane is C6H14. C6H14. So my mR is 6 carbons, 6 times 12 plus 14 hydrogens, 14 times 1, and that is equal to 86. So my moles of hexane is my mass, 1.29, divided by the mR, which is 86, and that is equal to 0.0150. So therefore my enthalpy of combustion of hexane is the energy that's gone in to raising the temperature of the water by burning my 1.29 grams, which is my 0.015 moles, divided by the number of moles that I've burned, 0.0150, and that equals 2508 joules. The question wants the answer in kilojoules per mole, so that is equal to 2,508 kilojoules per mole. Almost there, but I've still got a couple of things to do. First of all, I've got to think about the appropriate number of significant figures. So far I've got 4 significant figures in my answer. Normally we would look for 2 or 3, and the answer as to which one to use, we have to look at our input data and see how many significant figures are in the data that we used. So 3 significant figures there, 3 significant figures there, 3 significant figures in my delta theta, so it's appropriate to use 3 significant figures, which will be 2510. Not quite finished. This is an exothermic reaction. I'm heating up the water. That's how I know it's exothermic. The temperature of the water is going from 20.5 to 65.5, and we know that exothermic reactions have negative values of the enthalpy. So I have to make sure that I get the sign correct. So my answer is minus 2,510 kilojoules per mole. The second part of this question is also pretty typical. The calculated value of the enthalpy for combustion from this experiment is different from the data book value and suggests 2 reasons for this difference. What they're asking us here is to think about the errors in our experiment. We assume the data book value is correct, so we're looking at the reasons why our value from our experiment might be different. And the first reason, and this comes up every time when we're talking about these sorts of experiments, is that we are measuring the heat that's gone into the water, and we are assuming that that heat has come from the burning of the fuel of the hexane, and all of the heat from burning the fuel has gone into the water. Well, that's clearly not true, because some of that heat energy is released to the surroundings. So some heat is released to the surroundings rather than raising the water temperature. So we're actually underestimating the amount of heat that we're getting out from burning our fuel, because we're only measuring the heat that goes into the water rather than the heat that's going into the surroundings. And the second reason why there's possibly a difference comes from the definition of the enthalpy change of combustion, which is the enthalpy change when 1 mole of a substance is completely burned in oxygen. If we do not have complete combustion because we don't have enough oxygen, then we will get a different value for the enthalpy of combustion. So the second possible reason is that there is not enough oxygen around, not enough oxygen present for complete combustion to occur. And that's a fairly typical question. Sometimes, as a follow-up to asking you about the errors, they may ask what you might do about that. So we would look at ways of using a calorimeter, an insulated calorimeter, to try and minimize heat losses to the environment. And that's the sort of thing we'd be talking about if we had that sort of question to deal with.